Hello my esteemed viewers. In this tutorial we discuss clearly the preliminary learnings, the starting stage of learning exercise by human beings. Before I take on to the subject, the concept learning is the first thing that happens in human beings. It starts right when the baby, it is said, when the baby is around 6 months old. And before I complete this tutorial, before I complete this particular slide in particular, you would have identified this as an elephant, this as a tree, even if some of the salient parts are missing, and this as a bird. And in general, this is an elephant. It's a particular concept. It's a particular idea just about an elephant. This is a particular concept. It's not a general concept. This is a particular concept which is pointing to a tree. Even if some of the parts are missing, even leaves are not seen. It's a dry tree. If you want to be still particular, we may say that it is a dry tree, almost wilting tree. This is a bird, and we'll be just able to say the bird. And if you are poked further, we may able to classify this. But because we have the concept of a bird, concept of an elephant, concept of a tree, that is idea of a tree, idea of an elephant, and idea of a bird. And if I write this figure, and if we are asked to identify as to what is this, we may guess in a wrong way, or some of us may guess in a right way, because we have the concept of this, and we may just say this to be some kind of a vegetable or a fruit looking something like this, and actually this is the back view of an elephant. Because we don't know the concept, we are not used to this kind of a concept, we are unable to classify this as an elephant, though it is in some other orientation. Of course, the concept learning, also known as by variously called as category learning, concept attainment, concept formation, is largely due to the works of Bruner, a cognitive scientist and human cognitive learning expert, way back in 1967. He proposed the theory of concept learning as to how human beings start their learning exercise or learning mode in their early ages itself. Concept learning is basically a strategy which helps a learner to compare and contrast groups or categories that has concept related features. In order to categorize an elephant to be an elephant, it should come with all the features. Even if we write a line diagram of an elephant, we will be able to classify, because this line diagram would have encompassed all the features, necessary features, in order to categorize an elephant to be an elephant. The concept related features must be there in order to categorize a particular figure, particular process, particular entity, or whatever into a particular idea. Human beings will learn the concept by experience or experiential learning. As far as machines are concerned, they should be shown set of examples along with the features and relevant labels. And if it happens to be some kind of a conjunctive relationship, if an entity has a beak and a crow and a let us say the wings, and of a particular color, makes a particular kind of sound, then we will identify that to be a crow or a pigeon, something like that. Therefore, machines should be shown examples, and they should also be shown the related features also. By the by, it is a search. Concept learning is a search, and where listing of attributes will be made in our mental frame, and these attributes will help us to distinguish exemplars or examples presented to us or presented to a machine from non-exemplars of various categories. And more simply told, concepts are mental categories that help us to classify events, ideas, processes, entities, and objects. Concept can be viewed as describing some subset of an object. Let us say a group of wild animals, a group of farm animals, a group of pet animals from among a larger set of animals. Therefore, concept emanates from a larger set, because when we are bent on a particular concept, we will try to identify that particular concept even from among a big set of the same category or same type. Alternatively, each concept can be thought of as a Boolean-valued function defined over a larger set. A Boolean-valued function is defined over all animals whose value is true for birds and false for other animals. And once again, the output of a concept learning, as far as machine is concerned, is either 1 or 0. So if it is 1, it is a positive example under that particular concept, under the umbrella of that particular concept or particular idea. Otherwise, it is not a positive example. It could be regarded as a negative example. That means concept learning, as far as machine learning parlance is concerned, it is inferring a Boolean valued function from training examples of its input and output. A concept is an idea of something formed by combining all its features. Combining means here it's a logical combination. If this is true, this a particular attribute value 1 and attribute value 2, attribute value 3, attribute 3 value something. Okay, now that means we have to match attribute values in order to categorize a particular concept to be a real concept that is being probed by the machine. So in doing so, we will come across attributes. There should be an attribute set in terms of values, of course. In terms of values, attributes are general variables or characteristic features, but these features should have a value associated with that particular concept. For example, if the concept is a tree, then attributes are a trunk, the girth of the stem, the leaves, the status of the leaves, let us say, and the width, the area, the canopies of the tree. Is it present or is it absent? How long it is, and what is the characteristic features of the leaves, and all those things. And leaves forms a general name given to the attribute, but anyway, the value of the leaves, like wide or big or oblong, something like that, will decide the attribute values. A rule is to be framed that if an entity has a tail, if an entity will be panting always, and it barks, the sound is barking, then it is called as the concept is a dog. Okay, loyal to the let us say owner, like this. So we should first of all identify the attributes, and then we should fill up the attribute values, and we should train the system in order to categorize or in order to label a particular concept. The concept is a dog, the concept could be tree, the concept could be anything. First of all, we have to identify the generic attributes, then we have to fill up the values in order to delineate a particular concept as a pinpointed concept, pinpointed entity, or a specific entity. It is always generality towards specificity. Okay, concept learning must be distinguished from learning by reciting something from the memory. It's not a recall from the memory. It's not a recall from the memory. Suddenly, if a concept is known, concept is shown to us, and if you are asked to identify that particular concept, a particular idea, we will immediately go through the attribute values, and we will match. And if we find matching of the attributes that we know from years, let us say, we will be able to categorize it as a particular concept that we are being questioned. And it is not also discriminating between two things that differ. So concept learning is not this. Okay, this is a memory recall. This is a different exercise that is being done by the machines. We will also deal with this kind of a learning. But anyway, as far as concept learning is concerned, it is more or less some kind of a searching in the search space. The search space will involve different attributes of a particular category. Let us say tree is a concept. Then we need to identify a particular tree. We want to label that tree as a neem tree or a teak tree or a banyan tree, and we should match the attribute values. And if there are matching attribute values, then we will be able to categorize. And so also the machine. In order to as far as the machine is concerned, this is the machine generic definition of the concept learning. Concept learning is inferring a Boolean-valued function from training examples of input and output. So concept learning, as far as machines are concerned, machine learning parlance is concerned, we will develop a Boolean function. That Boolean function should yield 1 in order to categorize that particular input or instance of example to be a positive example. If it is 0, it can be considered as a negative example. So it's a training task. As far as machines are concerned, concept learning will engage the machine in a training task that makes a machine to learn some concept. This is done by showing the machine some predefined concepts with attribute values and the label. Attribute values, and it's a pair. The pair consists of attribute values and the label, the corresponding label. Attribute values are something like the wings are present, it will fly, it has a beak, it has a green color, its beak is little twisted or little cranky, and it makes tweaking sound. Then it can be called as a parrot, something like this. So it becomes a searching. As far as machines are concerned, concept learning is no more than searching in the space, in the huge space of a particular concept. Here the general concept is bird, and a particular specific concept is a parrot. Let us assume that tree is a concept. The features that determines it as a tree is trunk is present, it has a girth, leaves are present. Like that, we can extend the attributes to any number depending upon the situation. Belongs to the concept, otherwise it does not belong to the concept. We cannot show a machine some kind of an animal or some kind of a object and call it as a tree. Okay, as soon as it finds that mismatching attribute values, it will come out with a value 0 because it's a Boolean function. Concept learning task is a Boolean function. Okay, evaluating a Boolean function rather, as far as concept learning is concerned. Therefore, the outcome is either yes or no. If yes, positive example. If no is the output, then it is a negative example. So in order to do so, the machine makes use of general hypothesis and specific hypothesis. First of all, the machine will frame what is called as general hypothesis. Then it will search for a specific hypothesis. Specific hypothesis as far as specific output is concerned or specific identification is concerned. Okay, hypothesis generated in order to define a concept of a bird will become general. In order to identify a parrot, then the hypothesis should become very specific. Please bring me pizza or burger or pasta. This is a very general statement, and we may make this particular request over, let us say, attender. We may say, please bring me pizza, burger or pasta, and this is more specific request or specific assignment. get me pizza with which is loaded with onion, tomato, capsicum, sweet corn. Now he has to bring pizza with these features only. So his work will be, and his recognition of that particular pizza will become more specific. This is a bird. This is a general hypothesis. We will make use of a general hypothesis in order to call bird a bird, because we must have noticed that there is an object which is flying, which has wings, which has beak, okay, and all these things will make us to call it as a bird. And this bird is a parrot or a pigeon or a woodpecker. Okay, for this we need, our mental frame needs, so also machine needs certain attribute values matching. Color equal to green, and beak is present. Beak is little twisted or cranky, and it makes some kind of a sound very specific to parrot, and it eats only grains. It's a herbivorous let us say flying creature, something like that. Okay, in order to make the machine to arrive at a particular label called as parrot. This is an outdoor game. This is a very let us say general hypothesis or general observation or a very general statement, and this should be a football game. We are just tempted to say that this should be a football game because our mental frame must have matched certain attributes which are very specific to football game. These two kinds of hypothesis is the key to concept learning by machines. So here is there is a necessity. Let us assume that there is a necessity for a machine to identify the general concept of a bird. First of all, it has to recognize that it is a bird, and later on it has to identify that this bird is a parrot. So in generating general hypothesis, we will make use of the general attributes. The bird should have a color, the bird should have a beak, and it should have wing, and it should fly. Will it fly or not? That may be the thing. Attribute value here is yes or no. It eats what? And is it a bird? Yes. Okay, this will make so the characteristic features which are generic to a bird is to be first identified. Then, in order to call it as a parrot, the color should be green. The color is green. The beak is present, and wings are present, and it flies. Yes, it flies. It eats grains. Then it should be parrot. So while making this specific hypothesis or specific rule or specific constraint, we have used and. So therefore the rules and constraints will emerge out to be some kind of a conjunctive hypothesis. It becomes a conjunctive hypothesis. So this is a parrot, and if the color is brown and the beak is present and wings is present, it flies and it eats insects or grains, and also grains, then it is a bird, right? But it is a sparrow, like that. Hen, crow, and it is very important to identify in order to label. After having identified the concepts, the mental frame, and so also machines will match the attribute values with the actual values. And some of the attribute values may tend to be very generic. For example, fly. In order to call a bird, it should fly. So yes is the attribute value for most of the birds. And here, as far as hen is concerned, it could be red, it could be brown, or brownish red, or brownish yellow, anything. And the beak is present, wings are present, but it doesn't fly. It eats insects or grains. It is not a bird because a particular very important and very crucial attribute is missing. Like this, there should be matches and mismatches. So this is an eagle, something like this. So hypothesis will have a conjunction of constraints, or conjunction of attributes, or conjunction of attribute values rather, on instance of attributes, in order to specifically label a particular concept to be a particular concept, a concept of a bird or concept of a tree, into its own category, its own type, its own specific type. In this example, we will have 5 constraints. Therefore, we need to make use of a vector of 5 constraints, specifying the values of 5 attributes: color, beak, wings, flies, and eats, whether it flies or not. So the attribute value for this flies is yes or no. Eats, there could be 2 values for this eats. It could be grain or it could be some insects. Wings, yes, it is present or absent. Beak, present or absent. Color could be anything. Like this. Therefore, in order to identify bird, we need, in order to frame the general concept or general hypothesis, we first of all we have to define the attributes. Then, in order to identify in order to come to the specifics of the concept, then we need to match the appropriate values of all these attributes in order to label that specific concept, in order to go to specificity. So therefore, as far as the bird categorization of birds is concerned, we need a minimum of 5 attributes as a sequence of 5 attributes. This is called as quintuple. So whenever the concept learning happens, the machine is to be given a vector of attributes or tuple of attributes. Okay. And as far as values are concerned, to start with, we may indicate every attribute with a question mark. Okay, this is the knowledge representation. Of course, it comes in the artificial intelligence circles. So it can be represented by a question mark that any value is acceptable to start with. And we may come across specifying a single required value for the attribute. For example, in the case of a bird, is it flies? Yes. For any bird, as a matter of fact. It is a single required, but it is a required value. As far as color is concerned, color could be anything. And we may specify by 5 while starting of our learning process. Particularly with the machines, we will assume the starting point to be 5. This is a very specific value. We will specify. It is something like in programming language telling no data to be void kind of a data. Void means there is nothing. So telling that there is no data is also telling specifically that there is data, no data. So a function returns void data, a function receives void kind of data. Void is a kind of data itself in some of the programming languages. So it is we are very specific when we tell that no, this function doesn't send any value. No, this function will not receive any value. It is as good as telling it receives some value. This value is nil. A most general hypothesis to start with is any attribute value here, any attribute value for any attribute value for all the 5 attributes. The most specific hypothesis that none of them are positive example is 5. Okay, no value matching. No value is matching as far as all the 5 attributes are concerned. If some instance, let us say X, among the set of instances satisfies all the constraints of the hypothesis H, then H classifies X as a positive example. H of X equal to, this is a Boolean function. If all the values of this instance X, this is an instance of a bird, crow or a owl or whatever. Yes, it is a crow. It is as good as telling that. Okay. So we need to frame a Boolean function. Boolean function as an input. Input is a tuple. Input is a tuple of attributes with attribute values. We will never be generic. What is the value of the attribute? First of all, we will identify the attributes, I repeat, and then while categorizing or while identifying, we will just put the attribute values into exercise. It may turn out to be the target function happens to be a Boolean function. It may turn out to be either 0 or 1. If it is 0, then it is a negative example. If it is 1, it's a positive example. To illustrate, in case of a bird example, it could have any color. it could have any color. This is the more generalistic hypothesis that we can make. And the wings are present, it flies, so the beak is present, the wings are present, it flies, it can eat anything, it is a bird, still it is a bird. Okay, it's something like this. Hypothesis qualifies the instance to be a bird. To summarize, the bird concept learning task requires learning the set of bird examples for which bird equal to crow, let us say, describing this set by a conjunction of constraints over the instance of attributes. Color equal to black, and beak equal to present, and wings equal to present, and fly, yes, it flies and eats insects, then crow equal to yes. This is how we, from generality to specificity. Okay, and among the attribute values, it could be generic. We will have a question mark representation in order to say any color is possible, anything it may eat. Okay, another example we can take, this is water skiing, days on which Ram enjoys his favorite water sport. It also, whether he or she enjoys the water sport, yes or no, depends upon various attribute values. The sky condition, whether it is sunny or cloudy or rainy, temperature, whether it is warm or cold, or humidity of the ambient atmosphere, whether it is normal or very high, and wind, strong breeze or strong blowing wind or weak blowing wind, water, the temperature of the water, whether it is warm or cool, and forecast, and whatever that has been forecasted will remain the same, whether it is same or whether it will change. EnjoySport Yes. And if the sky is sunny, and if the temperature is warm and humidity is normal, wind is strong, water is warm, forecast is the same, nothing will happen, it may not rain, so EnjoySport is yes, definitely is going to enjoy. Each hypothesis in this case is a vector of 6 attributes. 1, 2, 3, 4, 5, 6. 6 attributes. Sky, the condition of the sky, air temperature, humidity, wind, water, water temperature, and forecast. What would happen to the forecast? So we will deeply deal into how exactly machine can classify, how to frame general hypothesis, how to frame specific hypothesis in order to label the things. Okay, in specificity also there could be generality by means of question marks, in terms of question marks. So to summarize, EnjoySport concept learning task requires learning the set of days for which EnjoySport equal to yes. See, this is our target function. It's a Boolean function. Whether Ram enjoys sport or not equal to yes or no. Okay, it will be no if none of the attribute matches. Example 3 we can take, and we can try framing how exactly what are the attributes and what could be the values, and here the origin, whether, and the manufacturer, the color, the year of manufacture, the type, whether it is economy model or sports model. Then there can be 2 classes, plus positive class and negative class. This is a classification task. Okay, concept learning is basically searching. Machine is shown several exemplars with attribute values. It's a supervised learning, but anyway the outcome is either yes or no, whether the concept is really the concept for which the machine is investigating, or it is not the concept. Okay, the outcome of the concept learning by any means, and this is the starting point of the learning, and this is the starting point of developing learning algorithms. There are huge repository of learning algorithms, out of which the concept learning stands to be a founding stone or a starting step for the machine learning related exercises. So with this we will close this tutorial, and in this tutorial we have understood as to what concept learning is, and as to, in order to make a machine to learn the concept, what all we are supposed to do. We have to identify the attributes, and we should also provide the machine with attribute values and the specific classification among the general classification, the general concept. The general concept is a bird, and the specific concepts that are needed, the specific concepts that are needed are the particular attribute values that will befit a parrot to be a parrot. So with this we will close this, and in the next tutorial we will come out with the higher versions of this concept learning with an algorithms, with a clear example of a clear explanation of algorithms. Until then, bye, and if you have liked this video, kindly subscribe to my channel. Thank you.